Alright, so this is section 9.2, piecewise functions. You want to be able to write and graph piecewise functions. And we want to use piecewise functions to describe real-world data. This is one of those you should definitely practice on because it can be a little confusing, but if you take it step by step, it should not be much of a problem. Okay, so you need to know what a piecewise function is. A piecewise function is a function that is a combination of one or more functions. So it's like you're going to have several different functions all together in one problem into one graph, and only parts of it at a time. Okay, so let's look at an example here, and I've got a drawing that I took from the book, and what they want you to do is take this drawing and create a table and verbal description to represent that graph. So you can see here on the graph we're talking about mixed nuts and how much they cost depending on how much you bought or how much in weight you bought. So if you see here, we're going to create a table first, and so we're going to put it up here like, again, the X would be your weight and your Y is going to be your price per pound. And here you notice we're going to write differently this time around, like how much it costs, or like what's the range from where it works to. So from 0 to almost 2 pounds. If you notice there's an open dot there at 2, which means you don't count 2. So the closest I can get to that would be, let's say, 1.99. From 0 to 1.99 pounds, it costs $8. From 2 to about 4 pounds, or close to 4 pounds, so we'll say 3.99, because again, that ends in an open dot, you'll put $6. And then they messed up on the graph there. It should start from 4 and have a closed dot. So from 4 on up, the price would be $5. Okay, so now what we can do with that is that we can say verbally that we want to say the cost of mixed nuts will be $8 if you buy anything less than 2 pounds. If you buy between 2 pounds to 4 pounds, you'll pay $6. 4 pounds or more, you pay $5 per pound. Okay, notice each of those is per pound. So like if you bought 1 pound, it's $8. If you bought 1.5 pounds, it's 8 times the 1.5. So you have to kind of keep that in mind. It's not just an 8 flat rate. And that's what we want to be able to do, be able to read those and kind of see how we can reword those. Another example from page 662 on the bottom of the page, you should see something that talks about green fees and times. And as you can see there, the earlier it is, the more expensive it is for the green fee, because that's a more opportune time. That's times when they know people would want to be there. So at 8 o'clock in the morning when they open up to do till about noon, they will charge a more expensive fee of what is that, $28. And then from noon to 4 they charge $25. And then from 4 o'clock till 9 o'clock, closing probably, it says there they charge a more opportune fee of $12. So you see in the mornings they're charging more because they know that's when it's cooler and people are going to want to be out there more, so they're willing to pay more. In the middle of the day they charge a little bit less, and at the end they're just trying to make sure they get some people out there, so they charge way less. Okay, now this also here, there's something important here. If you notice, these are all straight horizontal lines. When you have something like that, where it's supposedly constant all the way throughout each interval, that is known as a step function. Okay, and if you notice, the other one was also a step function. Okay, so now we want to evaluate a piecewise function. This is actually kind of the meat of this, this section, where I like to get a lot of questions for quizzes or tests. And since there are no quizzes, there'll be a test on this. You gotta go with that. All right. So what we want to do here is we want to evaluate a piecewise function at 2 different points. And the points I'm going to give you here are x equals -2 and x equals 5. And then I'm going to give you a function, and here's how you write a piecewise function. Notice here you got that little curvy kind of like squiggly parentheses thingamabob. That's like a set thing. And we got 3 different numbers here, -5, 4, and 12. And we're at f of x. The function is equal to -5 if x is less than or equal to 0. It's equal to 4 if it's between 0 and 3, and it's equal to 12 when it's greater than 3. So what you need to do to evaluate this is, write it like this, saying at -2, this is saying at -2. Which function to use, the first, second, or third one? Well, -2 is less than 0, so then that means you're using that first one, so at -2 it would be equal to -5. No substituting in or anything like that to solve, it's just straight numbers. That one makes it kind of easy. At 5, well, 5 belongs to numbers that are greater than 3, so it would be that third equation, which would mean then the answer would be 12. So the idea here is that you're trying to make sure that you pick the right function that it belongs to and then plug it in however you may need to. Okay, let's do that again. This time let's evaluate same numbers, -2 and 5. But this time I'm going to give you two functions. 3 of x plus 4 when it's less than 5, x squared minus 3 when it's greater than or equal to 5. So -2 is less than 5, so that means you would choose the first function, 3 times 3x plus 4. So I'm going to put the -2 in place of the x and say 3 times -2 plus 4, type that in the calculator if you want, is equal to -2. There's your answer, all done. 5 is equal to 5, so it would go into the second equation. So that means I would say 5 squared minus 3, which would be 5 squared, which is 25, minus 3 is 22. And that's evaluating piecewise functions. It really doesn't get much harder than that. You just need to make sure you pick the right one that it goes into, substitute in, solve, get your answer. There you go. The harder parts is graphing. I think most people have a little bit harder time with the graphing. And I'm going to actually show you a couple of different ways that we can do graphing. And the first way is something I just thought of this morning. I guess I had a actual genius moment. I don't know if I'm going to say that. This morning before I had my coffee, which doesn't happen too often. So here we go. On this, what I would do is this. If you notice here, there's boundaries. We're going to graph this. These lines right here, the x less than -3, -3 between, x is between -3 and 1, and x is greater than 1, those create boundaries. Vertical line boundaries. And you can see those vertical line boundaries there. Okay. You want to graph based off those. And what you could do, and I think this is actually easier, let's choose for like the first function, 3x plus 8. Let's choose two numbers for the x's that are less than negative, or that are at -3 or less. I would always choose numbers at the boundaries first, and then also choose numbers that would fit inside that area. So 3 times -3 plus 8 gives me an answer of -1, and I can graph that. 3 times -4 plus 8 gives me an answer of -12, -4, and I can graph that point. Connect those 2 points, make a line, you've graphed the first part of your piecewise function. Part 2, the -2x. Well, since there's two boundaries there at -3 and +1, I'm going to just choose those two numbers as my points, and then I'll connect those two dots because I know that line from in this middle section will be right there with those 2 points, and it's a straight line. So -3 times 2. Oh, and let me also make note here. Notice how it says x is less than or equal to -3, and I put a closed dot on the boundary. But on the next one, it's x is between -3 and 1 with no line underneath. That means you would put an open dot on those points. And then on the last one, x is greater than or equal to 1. That one is a closed dot. So you got to make sure you also have your open and closed dots, especially if the points don't touch. Okay, so let's look at this again. -3 times -2, plugging in the boundary point there, gives me a +6. So I would graph that point. And then -2 times 1 gives me a -2. So I would graph that point. Okay, so you see here I've got 2 points, and this is a straight line, so I would connect those 2 points, and notice they're an open dot because in that boundary the 2 points at the end are not equal to x. So you're getting close to those points but not there. And then finally for the x squared minus 3, I would start at 1 again. 1 squared minus 3 is actually negative 2, which would put me right back where that point is. So notice I'm putting an orange dot closed over it because for that one it's that closed dot. And then 2 squared minus 3, 4 minus 1 or 3 is 1. Put a point there. And then remember, this is squared, so it should be kind of curved, so I've made it kind of curved, and there's my graph. This is a piecewise function. I chose some points to help me graph the lines, and then that was it. You're done. You don't have to do it in different colors. I'm trying to do it in different colors so you know which ones I use or which sections responded to what. Okay, so let's look at another example. Negative 3x, f of x is equal to negative 3x when x is less than 2, and it's equal to x plus 3 when x is greater than or equal to 2. So here's 2 spots. There's your boundary at 2. So make a vertical line at 2. I think that helps a lot if you do that. Okay, so let's do at 2, let's say negative 3 times 2 is negative 6. So that would be that point. And then negative 3 times 1 would be negative 3. There's that point. And then I could connect those 2 points and make my line. And then for the next part, I'll do the x greater than or equal to 2. 2 plus 3 is 5, putting the 2 in place of the x. Notice that one's a closed up because that one had the line underneath. And then 3 plus 3 is 6. Connect those 2 points, make a line. There's your piecewise function graph. I've done this before, and that actually to me seems like it's pretty easy if you work it that way. It's different than what I've done before, so you might want to try that. I think it's easier just to plug a few points in, connect the dots, and there you go. For the last example, let's do this, and I'm going to do this based off something that was in the book. I think is like around 664 student to student, what one student says he does. So he graphs the function x plus 4 first. Okay, so that's a straight line. You start at 4, you'd go up 1 over 1. So starting at 4, go up 1 over 1, go down 1 and to the left 1, and then you could connect those points, make a straight line. Okay, then for the next one, negative 2x, there's no y-intercept, so you'd start at 0, then you'd go down 2 and over 1, connect those points, make your lines, then worry about your boundary. Now my boundary is at negative 2, so I'm going to put a closed, or I'm going to make my vertical line at negative 2, and then what I would do is erase. Now keep in mind that the top function is correct to the left of the boundary. So I would erase everything on the right for that top function. So and there I am erasing. Erase, 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 erase. Open dot because there's no line underneath. The bottom function works to the right of the boundary, so I would erase everything on the left hand side. Erase, erase, and put a closed dot. Like I said, this is the student-to-student tip that they did there, and that would be that one there. And there you go. You've got your graph for your piecewise function. Okay, so either method you can use. I don't care which one, whichever one you think might be easier. Alright, so now we're down to the last part, looking at a word problem. Look at the check it out number 4 on the page 665. It's kind of at the bottom. It talks about, say, somebody that's making $8 an hour when they work 40 hours a week. Anytime over 40 hours, they get $12 an hour. And they want you to write a graph or write a function that would show that and then try to graph it. So let's do that. And oops, went a little too far there. So we wanted to show that we're going to say here, the function written in terms of h. I'm using h as hours. So what do you do to figure out if you're making $8 an hour? Well, you say 8 times the number of hours, that's how much you're getting paid. So you can find out how much you're getting paid. But that only works if the h is less than 40 hours, or between 0 and 40 hours, because you can't have negative hours. And then you want to know that show that you can work 12 hours, but you're only or $12 per hour only if you go over 40. Well, how do you show that you've got over 40? How do you go with the hours that are just over 40? Well, if you work 44 hours, how many hours have you worked? Overtime. You've worked 4. 44 minus 40. And that's what you need to show here. So on the next one, we want to say that we're going to say 12 times, and to show it's just for the overtime hours, we're going to say 12 parentheses H minus 40. So that way you're only multiplying by the hours that are over 40 hours. Also, you need to add in the 320 because 8 times 40 hours is $320. So that way the graphs stay connected. So that 320 is already representing you've worked your full amount of time. That's how much you're getting paid in the first 40 hours. Anything over that, you're getting paid $12 an hour. That only applies if you've worked more than, if H is greater than 40 hours. Okay, now the graph of that would look something like, say, this roughly. Notice here it's going like at a certain rate, and then when it hits 40, it gets a little steeper because you're making a little bit more money per hour. But that's something wouldn't be too concerned about with. I would be more concerned with getting that piecewise function and making sure from the situation you could choose the correct functions that would fit that situation. That's probably how I'll write it on the test. If you do have any questions, feel free to send it to me through Edmodo. I will be out, and hopefully y'all will do the assignment that y'all should be doing. But again, if you have any questions, send it to me through Edmodo. Thank you very much.